lecture on the topic climate risk, adaptation and sustainable development. This particular course connects the climate with the risk, adaptation and the sustainable development concepts. So in lecture 1, let us first understand the basics of the climate, and all through this course we are going to discuss on Earth's climate. So let us discuss or know what is Earth, and particularly what are the different components, different variables that defines the Earth's climate. So to do this, I have divided this particular lecture into 3 components. So in first phase, we will understand what are the various components of Earth system. So, and the second one is various interactions between and among different components that exist or operate for the land and the atmosphere. So interaction between the land and the atmosphere. And the third is we will try to differentiate. There is a very minor difference between weather and climate, and then let us see what are the components as far as climate change and climate variability is concerned. So to do this, let us understand how the living world, that is the biotic system called or abbreviated as BIOS, interacts with the non-living world, so which is a geogenic, or you say sometimes we say it GEOS, geos. So together they form the term biogeo, or we discuss or study it under the framework of biogeosciences. So it is basically the components of the Earth system involve the interaction between and among the living and the non-living system. So living system are bio, so it has life, and rest of the components we put under geos. So on the left hand side, the schematic diagram connects that we can divide the whole Earth system, the climate of our Earth, into 4 broad systems, starting from biosphere, atmosphere, hydrosphere and geosphere. As we already know, bio for biological systems, atmosphere for atmospheric phenomena, hydro for water related things, and geo for the earth or earth science, particularly the geological features. And the various phenomena which actually are dominantly regulates, operates or impacts these 4 spheres are mentioned here. So these days the biosphere, we have for the activities such as dominantly deforestation, reforestation, afforestation. So these are all the vegetation related activities. Then we all are living in a developing world. We all are living in an industrialized world. So we have a lot of urbanization that is shaping the biosphere, or regulating the biosphere as well. So just as a symbolic, we have put these few terms like urbanization, deforestation, reforestation and afforestation. Coming to the upper right section is the atmosphere. So there we are talking about all the various gases. All of us know, starting from our high school days, we have the various gaseous components dominantly present: the nitrogen, the oxygen, the various greenhouse gases, carbon dioxide, carbon monoxide and many other trace gases and trace elements. So these form the gaseous atmosphere. And then coming to the lower left is the hydrosphere. In hydrosphere, as the term indicates, it is an interaction or it is an exchange among and between the 3 formations of the water. So water changes from liquid to solid to gas and vice versa. So we have a different type of phase changes. So this in turn regulates the water cycle and defines the dominantly, what you say, the regulates the hydrosphere. It triggers many activities including the agricultural activities, the biofuels, and many others. Coming to the fourth one is the geosphere. In terms of the geosphere, the geological, or you say rock, mantle, or our earth's crust, and the upper portion we say it as the soil, the upper few centimeters. So we have the interaction, so it can be bi, tri, and multi. So you have interaction between any two spheres, you have interaction among any three spheres, and among all four spheres. So this together leads to many other phenomena and activities we discuss under the biogenic volatile organic compounds such as BVOCs, the aerosols, the reactive nitrogen, and all this together also we try to understand throughout this course. We will try to understand in terms of their contribution and relevance to climate change. So biosphere, all the living organisms; geosphere, the crust, the mantle, and the core; atmosphere, the layers of gases around the earth; and hydrosphere, that mostly talks about the cycling, particularly among and between all the different phases of as far as water is concerned. In terms of the various interaction among the various spheres, we can also discuss, introduce them with the help of this depiction. So if you see here the changes in solar inputs, so solar radiation, the variation in the solar radiation, it's if you talk about the sun or the input solar radiation variation, which happens in terms of the dark spot and which are encircled or circled with the bright spots called faculae. So that happens at a 11-year cycle. But as far as the receipt of the solar radiation on the Earth's surface is concerned, we have diurnal variation because we have day and night, we have seasonal variations, we have monthly variation, and things like that. So this is a major variable as far as the Earth's climate system is concerned. Then coming to the next one is the changes in the atmosphere in terms of the composition and circulation, and changes in the hydrological circle. And on the terrestrial, as far as the terrestrial domain is concerned, we have the glaciers, the mountains, the human influences. As far as the agriculture is concerned, we have a lot of the industrial setups, we also have the urban setups. So all this actually makes the main formation as far as the terrestrial domain is concerned. And in terms of hydrosphere, we have ocean, the ice ocean, and the coupling between lake, lake water, various phenomena such as heat exchange, the atmosphere ice interaction, the terrestrial the precipitation and the evaporation. So all these terms we know, we understand more or less, which we are going to elaborate in the first part of this particular course. And they form dominantly the various interactions among various spheres, and what drives the various drivers, as we understand the water cycle, the carbon cycle as one of the dominant greenhouse gases, the carbon dioxide. So this we all are now bothered as far as the carbon, the methane, the water vapor, the nitrous oxide. We put these three as the well mixed greenhouse gases: the carbon dioxide, the methane, the nitrous oxide. So all this, as far as the greenhouse gases, they all are considered as the drivers. Then another important component of this interaction is, so through this interaction, what happens? Through the interaction, the exchange between energy and matter happens. So so this affects, this regulates in turn our life. This supports our life. So we put it under the whole of the interactions between and among the spheres leads to exchange of energy and matter. So this depiction has been taken from Bush et al. Publications, and which has been already mentioned in our references at the end. So now let us have a look at the vertical profile of atmosphere. As far as the vertical profile of atmosphere, we all know it starts with the lower one surrounding our atmosphere is the troposphere. So it is not a constant kind of definition. It varies from 10 and 11 to 16 kilometer at places. So we have a range there. So the troposphere, the stratosphere 15 to 35 kilometer, the mesosphere between 50 to 85 kilometer, and beyond that is the thermosphere. So as far as this vertical profile of the atmosphere is concerned, we divide them with a kind of zonation. So tropo, strato, meso and thermo. So as already have been told that the dominant composition of Earth's atmosphere is nitrogen, oxygen, carbon dioxide and many other gases. They in turn regulate the various climate variables or climatic components, such as the temperature, the weather pattern, and this leads to control of the heat exchange and also the greenhouse gas concentration. The atmosphere plays a key role to protect the life by filtering the harmful UV rays radiation. So it also through the hydrological cycle, it recycles the water and other chemicals. And also, as we know that since we have a greenhouse gas layer blanket around this, or which say the greenhouses which are present in the atmosphere, they fall in terms of a kind of layer. So this presence of the greenhouse gases layer in the atmosphere leads to a kind of, or give a kind of warming effect. So what does it mean? The Earth's average temperature is warmer than what it would have been without the presence of greenhouse gases. So the warming is, the effect of greenhouse gas warming is to the tune of 33 degrees centigrade. So friends, if the Earth's average temperature is about 15.6 degrees centigrade these days, had the greenhouse gases not been there, then the Earth's temperature would have, or the Earth's average temperature would have been less by 33 degrees centigrade. So it is very, very important. So that is why the understanding of the atmosphere, the different vertical strata is very, very important. Well, in this particular figure, we also have various cells, zonations as far as the Earth system is concerned. In terms of Hadley cell, intertropical convergence zone, ITCZ, we call it in terms of abbreviation. The Hadley cell, the mid-latitude cells and the polar cells. So we will be discussing them eventually when the atmospheric the lecture on the atmosphere will be in elaboration. Now let us move on to the hydrosphere. So this water or hydro is very, very vital as far as the Earth's water cycle and heat redistribution is concerned. So as all of us know, it covers about 71% of Earth's surface. It impacts life and health. And thereby it affects the Earth water cycle or hydrological cycle affects the climate. So these the three arrows which are shown there, the red arrow talks about the heat, the blue arrow talks about the water, and the green arrow talks about represents the carbon dioxide. So here if you see these major dominant components as far as the snow cover variation, decrease or increase, the glacier mass loss, and on the right hand side ice sheet melt mass loss, and down below you can see the changes in terms of the ocean heat content, in terms of the pH decrease which we discuss in terms of ocean acidification, and then the oxygen level decrease, or we say the ocean deoxygenation. So these are all the various processes which are we say which are happening, and we relate it to various activities, environmental change, change because of land use, land cover, because of human activities, but also many of them are triggered or are linked to the impact of climate or climate change. Okay, so the marine heat waves are increasing, the sea level is rising as a byproduct of global warming, and the the sea ice is melting. So these all we link it or relate to the impact of climate. So all this we put under the hydrosphere, how they are being affected, or they play a role which controls or which regulates the climate and the climate change. Similarly, let us go to the other part, is the geo, the earth. So in terms of the a vertical section, cross section has been shown here. This goes up to below, as far as the radius is concerned, 6371 kilometer depth. On the upper side we can see our the upper part of the earth surface, we call it the lithosphere, and down below as we go in the asthenosphere, the mesosphere, the endosphere, and the solid. So on the other side, this is in terms of the density level, and on the other side when we go down, we have the upper mantle, we have a kind of lower mantle, and in between you have a transition zone, and down below you have the earth's core and the earth's outer core and the inner core, which has the dominant composition as far as nickel and iron is concerned. So this also we will try to understand in terms of the plate tectonics. Friends, all of us remember that the outer layer of earth is broken into several plates, or is and it is always in a kind of constant motion, but the speed is very slow, so very slow to realize at a what you say very higher temporal scale in terms of months or seasons or years. But the moment as far as the convection currents in the mantle below this leads to the plate movement to the tune of 1 to 6 centimeter per year. So this slow movement is reflected in terms of the earthquakes, in terms of the volcanic activities, mountain building. So all this we realize, and we also have been realizing them more frequently these days in this warming world. So the geological component, particularly the geosphere, the Earth's surface and its inner layers, are needs to be understood, so that they form an important component of our system, or Earth's climatic system. Now let's come to the next one, is the interaction between ocean and the terrestrial biomes. So dominantly our living sphere. So the living organisms, they regulate climate through carbon storage, oxygen production, evapotranspiration, and influence the atmospheric composition. And let us have a word with respect to the carbon. Friends, there have been various budgets as far as the carbon is concerned. So in terms of the plants, the soil, the atmosphere, they contain different amounts of carbon. So lot of carbon, about as far we go, the budget, the total amount of carbon is 10 to the power 23 grams. Out of that, 99.96% of the carbon is buried in the lithosphere. So rest 0.4% or 0.4%, which is equivalent to about 40,000 petagrams of carbon, is there in an active circulation, active movement. So out of this 40,000 petagrams, again close to 38,000 petagrams of carbon is there in the ocean. So apart from that, Apart from that, around 450 to 650 petagrams of carbon. Why we are saying around? Because this margin is there 450 to 650, because many cases the budget or the estimation is still have a lot of errors, still have a lot of uncertainties in terms of regional, in terms of spatial, in terms of temporal, and all those things. So that is why there is a range as far as the quantification. So the plants, they have 450 to 650 petagrams of carbon. The soils, they have 1500 to 24 petagrams of carbon. And keeping this aside, the atmosphere is now getting loaded with more and more of carbon dioxide, increasingly because of the human interference, human activities. So just multiply, currently it is in terms of ppm, the CO2 concentration is about 425 plus. So 425, if you multiply with about 2.19 as a thumb rule, it will be more than 850 petagrams. So the atmosphere is loaded with more than 850 petagrams of carbon. So this is a kind of carbon storage, or carbon, the amount of carbon hold or present in different residences, though atmosphere is not, but atmosphere is now getting loaded with more and more carbon dioxide from rest of the sources. Rest of the sources are the lithosphere, are the carbonate rock and other rocks which store a lot of carbon. From they are escaping through different geological means, activities, the soil, the plants, and the ocean. And now let us look at this depiction, which talks about various interaction between and among the marine and terrestrial biomes. So the various activities, the various interactions, the various arrows and structural components and linkage activities are defining the various interactions between the ocean and the terrestrial biomes. Now let us move to the most interfering the interaction between the vegetation and its surrounding environment. So as far as this is concerned, we put it under bio-geophysical interactions, and this has been shown here using 4 plus 4, 8 different components or different subfigures. The first one is albedo. Friends, all of us know albedo is the reflectivity property of Earth. It talks about, or it depicts the surface energy balance, and also it has linkage, or it regulates, or it contributes to the climate and climate change. The second one, upper right, talks about the surface roughness. So what is the characteristics of the surface roughness? Is it smooth or is it rough? So because it has a lot of repercussion as far as the air flow is concerned. It influences the flow. The third one, we talk about the most important thing is the canopy processes. The exchange by the vegetation, the plant, leaf, in terms of energy, water, and gases through the process of photosynthesis, through the process of transpiration, happens at the canopy level through the pore called stomata. So this exchange of energy, water, and gases play a very, very important role in terms of regulating the plant-based carbon dioxide sequestration, because this is the only way of withdrawing the carbon dioxide from the atmosphere by the process of photosynthesis. So it involves the canopy ecophysiology, involves the exchange, or involves and regulates the exchange of energy, water, and gases. Let's move on to the fourth one, that is the soil moisture. Soil moisture regulates the evapotranspiration, the temperature, the precipitation, and their feedback. And as far as the fifth is, the next one is concerned, is the carbon. I just mentioned the different amount of carbon present in different spheres. So here, in terms of the carbon, we have the GPP, gross primary productivity, the feedback, the warming, or RE, we call it the respiration, sometimes we call it maintenance respiration, and then other activities also leads to the carbon what you say pathway or carbon cycle through the vegetation route, like reforestation, afforestation, deforestation, the high carbon storage and all those things, which is shown on the upper left side. Then coming to the upper right is the reactive nitrogen. So all forms of nitrogen except the inert ones we usually define as the reactive nitrogens. And then the ecosystems, they emit reactive nitrogen, altering the atmospheric chemistry, aerosols, and the radiative forcing. And the lower left talks about the aerosols. Friends, all of us know aerosols act as the negative radiative forcing. So where from these aerosols come? They come through different routes, particularly let us understand the biomass burning through fire, the particulate matter and the particulate matters that are emitted because of the wildfires. So the black carbon, the aerosols that affect radiations, climate and cloud processes. So their understanding in terms of aerosol loading is very important as far as the climate component is concerned. Then coming to the volatile organic compounds, as far as the biogenic sources is concerned, vegetation also emits some VOCs that drive the ozone formations, methane lifetime, and the aerosol production processes. So this is very well defined by Gordon Bonan in his book on ecological climatology, which has also been referred here. And let us come to the last but one slide that talks about the climate versus weather and the climate change and climate variability. Friends, often we are confused a bit. There is a very sharp differentiation between these two terms, between the weather and climate. As far as weather is concerned, we generally say that what is today's weather, but then we say that how is the climate of that particular place. So that means the moment we say the weather, that means we are talking about a very short-term phenomena or state of the atmosphere. So that can be at a minute to hour, to day to month, to a seasonal time scale resolution. Then the variables, different variables that define the weather of that particular place or area in terms of weather or climate. We take help of the temperature. Yes, the temperature range is this much, we say. The precipitation amount is this much. The humidity pattern is this. The cloudiness, the wind, the atmosphere pressure, the sunshine, the brightness, all these actually are the different variables that define the climate or the weather of any area. Then in contrast to weather, the climate is defined as the long-term average of weather patterns over 30 years or more. Look at we are talking about Earth's climate, and Earth's origin is about 4.56 billion years old. And when we talk about billion, so we know that 1000 million is a billion, okay, and 1 lakh years is 1 million. So, and then we talk about the climate in terms of the from methodological point of view. When we talk about the climate or climate data, we usually take at least 30 years data to deal with or to analyze the climate of that region or that particular area. So that we put under a long term. It's not long term, but relatively longer term. So long term average of weather pattern to the tune of 30 years or a plus for methodological reason are taken as consideration of climate. So then this climate regulated by the dynamic interactions among its major systems in terms of atmosphere, hydrosphere, biosphere, and the lithosphere. Now coming to the climate change and climate variability. So the climate variability in terms of short-term variations in climate. So phenomena such as El Nino, La Nina, droughts, the multi-year, multi-decadal, multi-century changes in terms of temperature and the precipitation pattern, temperature, precipitation, and many other variables, those patterns, they define that. So these we put under a climate variability. So this year is drought, the multi-year drought, the El Nino pattern, the La Nina pattern that controls or that defines a broader range precipitation controller, deficit or plus and minus. So these are the various short-term variations in the climate. Now, in terms of the longer time scale variability, such as a series of abnormally mild or exceptionally severe winter over a place. Look at the Dras sector over Indian region. So these all actually help in characterizing, these variables help terms help in characterizing the climate variability. Now coming to climate change. So statistically significant variation in either the mean state of the climate or in its variability persisting for an extended period, typically decades or longer, we put them under climate change category. So changes in the global energy budget due to increase in the greenhouse gases, gas concentration, deforestation, all this actually impact or affect the climate change. So more about the various mechanisms that explain the climate change will be discussed in future, and these are the references that have been used for this lecture. And now let us summarize and let us conclude what we discussed as far as the basics of Earth's climate is concerned. So as far as the basics of Earth's climate is concerned, the Earth system includes atmosphere, hydrosphere, biosphere and geosphere. These components exchange energy and matter through cycles like water cycle, carbon cycle, nitrogen cycle, many other cycles are there. So they cycle between and among all these four broad spheres that we discussed here. Weather is short term and local phenomena, while climate reflects a longer term pattern. The natural factors such as volcanoes, the tectonical movement, the human activities such as which are triggering these greenhouse gas emissions and land use changes, they all are dominant factors contributing to recent days faster climate change. The fifth point or the last point is such interactions lead to global warming and increased climate variability. So this is what we discuss. So I'll just wrap up this. We discuss all four different spheres: atmosphere, hydrosphere, biosphere and geosphere to understand the basics of Earth's climate systems, and the interaction between and among these spheres regulate the climate and the climate change, and the various climate variables are required or are needed to judge, to characterize, to define the climate change. And this concludes today's lecture. Thank you very much.